Dear students, today I'll be taking up one of the most important topic of the chemistry, which is tetravalent nature of carbon. Now, before going into the detail of the topic, I would like to give you very important features of or the properties of the carbon atom. As we all know that carbon is the important element of all. It forms number of millions of the compounds in nature. What is the atomic number of carbon? That is important to know about. It is 6. Second, what is the electronic distribution of carbon, or you can say simply what is the electronic configuration? I hope you all will be knowing about configuration of electrons. It is actually the distribution of the electrons within the shells of an atom. So how those 6 electrons are being distributed? 2 are being distributed in the inner shell and 4 of 6 electrons are being distributed in the outer shell. So these 2 electrons go in K shell and these 4 electrons go in L shell. Okay. Third important feature is the valency. Again, I hope you all will be clear about the valency. What does the valency mean? Valency means the electrons which are present in the outermost shell of an atom. Here, what are the number of electrons which are present in the outermost shell of the atom? That are 4. So, here in case of carbon, we have got 4 electrons in valence shell. So, the valence electrons are 4 in number. Okay. Now, as we all know, every atom has to complete its octet rule to become stable, to get the next stable electronic configuration as according to the noble gas electronic configuration. Here, to complete its octet, carbon has to get 4 more electrons to form 8 electrons in order to complete its octet rule. Okay. Now, for carbon atom, there are 2 possibilities. One possibility is carbon can either accept 4 electrons, okay, so that it can become carbon cation or carbon anion, or carbon can lose 4 electrons okay. Either it can, there are now the 2 possibilities for a carbon atom to complete its octet. Either it can lose 4 electrons to form C4 cation, or it can gain 4 electrons to form C4 anion. However, both these conditions are not possible for carbon to go for. Neither this condition is possible nor this condition is possible. Why so? Here we know that carbon atom is having very small size. If carbon atom will go on pulling in electrons, these electrons, again, if it goes on pulling in 4 extra electrons, what does it do? There will be the strong repulsion between electrons. The repulsive force between the electrons will be strong. So they will be going on repulsing each other with the stronger force. So that is why this condition is not possible. Again, due to the small size, we already have 4 electrons in its valence shell. Due to the small size, the distance between the electron and the nucleus of the atom is very short, which means that there is strong force of attraction between the electrons and the nucleus, a very strong force. And in order to pull out or to extract any of the electron from the outer shell of the carbon atom, we require large amount of energy. Again, that is not possible. So both of these two conditions are not possible for carbon atoms for carbon atom to attain its stability. Now, what does the carbon do? There is one important thing or important activity that the carbon does to attain its stability, that is, it can share, since it is having 4 electrons in its valence shell, now it can share its electrons either with the same carbon atom or with the atom of other elements, only just to attain its stability. What does the carbon do now? It can share its electron either with the atom of the same element or with the atom of the different elements. This here sharing occurs between either the two carbon atoms or either between the carbon and some atom of the other element. Now what happens here? By this sharing, carbon attains 8 electrons. It is 1, 2, 3, 4, 5, 6, 7, 8. By this way, carbon attains its stability. It follows the stable octet rule. And in this way, carbon can form 4 bonds by mutual sharing of the electrons. Since by this way, carbon forms 4 covalent bonds, we can say that carbon is tetravalent in nature. And due to this important property of carbon, it can form millions of compounds by sharing its electrons, by forming the covalent bond with the other atoms of the other elements to form millions of compounds. Today, we can see millions of compounds which are already found in the nature, and thousands of these compounds are being synthesized on daily basis in the laboratory under the laboratory conditions. So the question now here, important question arises. Number 1, as I have already discussed, still we can impose some important questions like why carbon can't lose 4 electrons. It has the ability, it can lose the 4 electrons only to keep 2 electrons in its inner shell. Again, the answer lies in here that it cannot lose all its 4 electrons. And second one is why carbon can't gain 4 electrons. Again, it can't gain 4 electrons because due to the small size, it cannot gain 4 electrons. It has small size. It cannot keep extra electrons there, and due to its small size, there will be the repulsion between the electrons, which is not possible. Neither it can lose all 4 electrons because in order to pull them out, in order to extract all those 4 electrons, we require lot of energy to attain the same. So, next important question would be why carbon can form important these multiple bonds with the other carbon atoms. Again, the answer lies here due to the tetravalent nature. What is now the tetravalent nature? Tetravalent nature of the carbon atom is that it shares its valence electrons with the electrons of either the same carbon atom or the atoms of the other these elements. so that it can form the multiple bonds with the atoms or like oxygen, nitrogen, sulfur, and to form, so that it can form millions of the compounds. I hope this topic is a little bit clear to you all. In order to get more clear vision of the topics or our future topics, you can subscribe our YouTube channel, which is Cash Concepts. Thank you all.